Cool. Can everybody see that? Yeah. All right. I think it's time. Let's go ahead and get started. Well, I'm really excited to be here. We're going to talk about some front-end UI component-based JavaScript today. Before we get going, just a quick intro. I'm going to try to stand as still as I can. I'm usually moving around, but I'll stay next to the mic. So I'm Tyler. These are the places you can find me on the net. My slides today are in Vim. If you hate them, if they're really ugly to you, you can hit the link on the right there, tybenz.com. There's a link that I posted to a nicer looking slide deck if you want to follow along there. Or if you just want to check any of these links out, feel free. So some things you might know me from. One, this project here. So the Vim slide deck thing is an open source project that I maintain called VimDeck. You guys can check it out if you're interested. I also started a link spammer a couple months ago. I just kind of collect random web developer related links throughout the day, and I send them out to a Twitter account, website. There's a weekly newsletter. There's even an IRC channel where there's a bot that kind of puts out the links. So feel free to check those out if you want to stay up to date on the kind of stuff that I'm reading. And professionally, I work at Adobe here in town. When I was hired on at Adobe, I was hired into a team that was contributing to jQuery mobile full-time. And so it was a great experience getting to work with jQuery and getting to cut my software engineering teeth in the open source world, which was a lot of fun. I worked on Theme Roller for jQuery mobile in that time. And after Theme Roller was released, our team kind of got repurposed. So our new goal was to sort of prototype and kickstart these new product ideas, and we were web guys, so we were going to do it all in HTML5 and JavaScript and CSS. But when we started this whole thing, we knew that we were going to end up kind of rolling a lot of our own UI components as we went, and we wanted to come up with a clean, reusable way to kind of take a stockpile of JavaScript components from project to project, regardless of how the HTML or CSS had to change. So we wrote this little widget framework, and we called it Web Pro. It's not open source, but a lot of the concepts are kind of present in this talk. I learned a lot from kind of writing components in this way. So we're going to kind of step through it. So today we're going to cover three main things. We're going to go through UI patterns, look more at a design level, some visual examples, and talk about looking at a piece of UI, how would you go about implementing it, and trying to understand the underlying behavioral patterns that are going on. And that can shed some light on how you should organize your code and think about implementing UI in general. Then I'm going to get a little bit preachy on decoupling your markup, your CSS, and your JavaScript, and why it's important and sort of how it's done. And then at the end, we'll hone in on a concrete example in the JavaScript and kind of go over some criteria for writing truly solid, reusable UI components in JavaScript. So let's talk about UI patterns. So for this next little section, we're going to look at some visual examples. I want to talk a little bit about how we would go about implementing them without actually putting code up on the screen. So we're kind of thinking in the mindset that we're building our own small UI library. I know that's not practical for everyone in here. Your day job, you might not have the time to roll it yourself. You might be depending on third-party libraries. But in general, I think this is kind of enlightening to start thinking about UI in a different way. So I want to start with this example. We have this slider on the screen. It's pretty basic. We've seen these before. But if we were to go ahead and kind of roll our own slider and write this thing from scratch, I just want to kind of step through and walk through and see if we can find any patterns that we might be able to pull out that might be useful in other places along the way. So you want to implement a slider in the web. You need some HTML. There's basically two elements here. We have the thing that's moving on the screen, which I call the thumb. The thing that's moving inside, I call the track. So the whole point of a slider is user moves the thumb, the position of the thumb relative to the track maps to some arbitrary value. Usually a slider component will have some sort of external API to allow some other component to ask for its value in a percentage, and then you can convert that to whatever you want. So if we're going to write this slider, we need to have some HTML and some CSS, and then our JavaScript needs to basically set up the ability for the user to move the thing, and then some sort of API to reveal the value of the slider. So when we talk about the behavior here and the underlying pattern, it's the ability to kind of drag something across the screen, right? We all know that that's pretty common in UI. So before you actually sit down and just write a slider and put all that functionality right there, it's a good idea to kind of abstract out that underlying behavior. So we could write a component that handles just the drags, right? jQuery UI does something similar. They have a component called a draggable. It's a nice little chunk of code. You just pass in an HTML element, and it sets up all the drag stuff for you, and you can drag the item around the page. So we could write something simpler. We could stop, write our own draggable, and then build on that and write a slider on top of it. One other abstraction that we made in Web Pro, which I found pretty interesting, we called it a drag tracker. So if you think about the draggable by itself, you really, the component is setting up this behavior of a full drag motion, right? I mouse down, I mouse move, I mouse up, or maybe it's touch. And that's nice to have, but you have this like bound behavior of while the mouse is moving, the element is following the mouse wherever it goes, which is good for the draggable, but there might be cases where you want the drag events and you just want the raw data and you can decide what to do with it. So we wrote this little utility called the drag tracker. It's very similar. You pass it an HTML element, it sets up this drag motion, but while it's dragging, all it's doing is reporting back the mouse position, and you can do whatever you want with it. So it sounds a little abstract. Let me show an example of what it might be used for. This is a numeric spinner that I wrote. It's typical numeric spinner. You can increment and decrement the numbers using the arrow keys or these buttons. You can press and hold whatever you'd like. It has this hidden feature, though, where if I start a drag on either of the buttons and I go upward or downward, the numbers change along with it. So it's kind of this invisible slider. It's not the most discoverable feature, but it might be nice if I want to dial in a number really quickly and it happens to be a large number. Some of the Adobe components use something like this, but a draggable wouldn't work for this, right? Because a draggable means something's following the mouse wherever it goes. Here, it's more like this utility that you wire up, and you can do whatever you want with the mouse data. In this case, I took the mouse position or the difference from the start point and mapped it to a number. So just a simple example. So we can make that abstraction, right? We can write this little drag tracker component, and that can do whatever we want down the road. Then we can build our draggable on top of it, basically take a drag tracker and set the little update notifications to move the element wherever the mouse is going. And then once we have our draggable, we can write our slider, and we're ready to go. So that's just one example. Let's go over another one. Here is a color picker. I just want to focus on the two elements that we see on the left-hand side. So we've got this square, and the user's dragging something around in it. And then we have this rainbow thing. So the way color pickers work is we need three values. We need hue, saturation, and lightness. The little rainbow vertical thing is the hue. The saturation and lightness are determined by the position of that little circle on the left-hand side. So let's talk about the hue selector. It's simply just a slider, right? Hopefully when we wrote our slider, we thought far enough advanced to have either horizontal slider or a vertical one. So this is just a vertical slider, and we map the value to the hue. That thing on the left is a little trickier, right? We have this drag behavior. We could use something like a draggable to implement it. But you're going to find out that you're mapping a value based on that position, just like we were in the slider. So what I did, I went back into my slider and I modified it to either allow for horizontal or vertical or both, right? Now we have a two-dimensional slider. We can report the X and Y values back independently, and we can map those to saturation and lightness. So the whole concept here is making these abstractions just by understanding what's going on the screen. You can write your code a little better. Now we've got these building blocks, and we have a lot of shared code as we kind of build out these components. So here's a really interesting one. This was an eye-opener for me. We have this thing on the screen. I apologize for the speed. It's navigation. I'm going to go ahead and call it tabs. Some people get nitpicky about that. They think tabs are on the top. You got to click on them. In this case, they're on the left. We're using hover. Really shouldn't matter, right? The whole point of tabs is we have a set of links that map to a set of panels, and only one link and panel combo can be activated at one time. So if we're going to implement something like tabs, the first weird thing that we did in Web Pro, which I found interesting, and I'll explain more why we did this in a bit, is we decided to split tabs and panels into their own separate components. It sounds odd. I'll explain why in a sec. But let's just think about tabs by themselves. The links that we see on the left-hand side here, if you want to implement a component that kind of manages the state of this thing and the user interaction, what would we have to do? Well, if we think about the underlying pattern that's going on here, we have this set of links, and only one can be active at a time. That's actually really common in a lot of UI. In fact, in the web, we have a native form control that does this, the radio button, right? You have a set of radio buttons, only one can ever be active at a time. So we decided to bank on the fact that we would need that basic behavior and a few other components, and we wrote this base class that handles that simple behavior, and we called it a radio group. So we have this base class which handles a set of stuff, only one can be active at a time. So if you ever activate one thing in the list, we deactivate everything else to make sure only one's active. So that's taken care of. Then we wrote our tabs to kind of derive from that because they have that basic behavior. We set up some, in this case it would be hover, or you could do click or whatever. So our tabs are taken care of. We have this base class radio group. Let's look at panels as a component by themselves. So it's the same thing, right? If you look at the right-hand side, we have a set of panels, and only one can be active at a time. Now, the inactive state for the panels looks a lot different than the inactive state for the tabs, right? An inactive panel is totally hidden. An inactive tab is always visible. But I'm going to argue that that's just CSS, right? And we're going to get to that in the next section when I talk about separating those things. So if your JavaScript only cares about maintaining state of these elements on the screen, it's the same behavior, right? I have a set of panels and only one's active at a time. And the active panel is linked to the active tab. So we can actually take our panel component, when we write it, we derived it from the same exact base class. It has that radio group tendency. So they're actually sharing code, both your tabs and panels, which is really clean. Because if you need to make fixes or whatever, when it comes to maintainability, it's nice to have that hierarchy. So we have tabs and panels, they're separate. And now we can add a mechanism to each to keep them in sync, right? Such that when I click on a tab, I get its matching panel. And the radio group behavior makes sure that only one of each is showing at a time. So we went ahead and did that, and we were right to split them up. We came across a few examples where a designer would send us a comp. We would start building out just the raw HTML and CSS, and we would realize that the pattern that was going on the screen was sometimes a single set of tabs that drove two different sets of panels. So a lot of like third-party UI libraries will just implement just a canned tabs widget and give you the markup that you need to do it. We have this flexibility of managing them separately. So they can be in completely opposite edges of the page. You can click one tab and activate two different active panels in two completely different sets, which I found really nice. And actually, we'll see an example of that in a second. But one other thing I want to highlight here is this screen. This is kind of the eye-opener. So we talked about the radio group behavior. We talked about how we did tabs. All three of these things are just an instance of a tabs widget, right? It's a set of links and there are panels. So we're familiar with tabs, accordion, and slideshow, but they all actually have the same behavior if you write it the right way, right? I don't care what my HTML, CSS look like. I just care that the JavaScript can maintain the state of a set of links that map to a set of panels. So I can ship things around, but it's the same behavior, right? The only thing extra here is the slideshow. The slideshow has this autoplay behavior. Actually, let me refresh here. The slideshow has this autoplay behavior, and I had controls down here, and they seem to have broken on me. But the idea is that these thumbnails here map to the active image in the slideshow, and I can activate either of them. And then there's some autoplay controls as well to kind of increment it through. But again, the whole idea is it's just one set mapping to another set. So we happen to implement all three of these things using the same code. If you go to like a popular third-party UI library, they might have three completely different components to handle these three things. And they've actually written them differently when in fact they're rewriting a lot of the same code because they missed out on the underlying pattern. All right, so lastly, this one. So we talked about UI patterns helping you understand how to organize code. I like to use this slide to illustrate how UI patterns can kind of help you not go crazy when a designer sends you a comp like this, right? If someone sent me this, the first thing I'm freaking out about with HTML and CSS is circles are hard, period. The second thing is the JavaScript looks crazy, right? There's a lot going on this page. There's a lot of animation, there's a lot of motion, there's a lot of interaction. Once you have an understanding of UI patterns, you can break this thing down into some really simple components. So let's talk about it. Let's look at, so first, I'm going to assume that I guess touch is driving this thing. I just found this on Dribble. Some guy came up with that. I think it's pretty cool. But let's talk about what the interaction is. So we want to basically tap or click on one of the icons, and then the state of the whole thing changes, right? So I'm going to argue that the icons that are arrayed around this circle, the 8 different icons, are just tabs. And if we focus on what's happening in the center of the circle, as the user activates Wi-Fi, we get a Wi-Fi icon and a little bit of data. Then when the user activates volume, we get the volume in the center. So I'm just looking at the middle. So that middle section is actually just another set of panels. So if I have 8 tabs around the circle and I activate one, I get its corresponding panel showing up in the middle of the circle. Now, if we talk about what's going on the outside of the circle, again, we have some state toggling, right? I have buttons showing up when I hit Wi-Fi. I have this kind of circular slider showing up when I hit the volume. Again, we're just toggling state, but this time it's a separate part of the screen. So that can actually be a second set of panels, right? I tap on one, And because I've written my tabs and panels separately, I can drive two different sets of panels with one set of tabs. So the JavaScript is actually already done for most of this. The only other thing we might need to do is implement this circular slider. Admittedly, not the easiest thing, but since we have something abstract like the drag tracker, it would really come in handy with this, right? We can basically track the user's touch around the circle, calculate some sort of radius, and then we might have to use something like SVG to render this kind of arc that gets filled up either with blue or gray. So admittedly, the HTML and CSS is the hardest part of this, right? But the JavaScript is almost already done. The only other little bit of JavaScript we might need is something to track the mouse or something like that, whatever's driving the movement of this blue wedge that moves around the circle. So pretty easy. So again, UI Patterns is all about understanding what the underlying user interaction is and being able to organize your code to take advantage of it. So that's it for that one. Let's go ahead and move on and talk a little bit about decoupling your code. So you are a front-end developer. It's really important that you kind of understand these staples. It's all about separation of concerns, right? So HTML is responsible for structure. CSS is responsible for style, the look and feel. And your JavaScript should just be responsible for behavior and interaction, a little bit of logic. There shouldn't be any overlap between these three things, as little as possible. So what this actually means is style only happens in your CSS. And what that really means is style should not happen in your JavaScript. So who here uses jQuery? Raise their hands. Cool. So if you've ever used .css, that's just setting inline styles on an element. And the problem with it is you're setting style properties from your JavaScript. What you should be doing is putting your style in CSS in a class, and you can drive the toggling of state in JavaScript by using add class or remove class. Same thing if you've ever used .style. Who here has used jQuery's .hide or .show before? It's a nice handy method. I've been there, you're prototyping something out, it gets it done. But again, what you're actually doing is toggling state. What you should have is a specified CSS class for that state, and you should be adding and removing classes. .hide and .show are doing inline styles under the hood, and it's considered a bad practice. So style should only happen in your CSS. Anything, look and feel-wise, needs to go in your CSS file. You can drive it from JavaScript by toggling classes or attributes or whatever you need it to do. But in general, we're trying to isolate the look and feel to CSS. In addition, same thing with animation, right? CSS transitions and animations are well supported now. They're performant. This is a rule of thumb. There are cases where it's not possible to always do animation from CSS. But when possible, you should do it. And again, you can drive these animations by adding classes and by hooking into animation end events and things like that. The support is there, so we should be doing it. Your JavaScript shouldn't care about the specific look or feel or motion of a specific part of your application or site. So, and then lastly, your JavaScript should care as little as possible about the structure of your markup, right? There has to be some coupling, right? I have to be able to use selectors in my JavaScript, but they shouldn't be tight selectors. It should be something really loose so that I have the freedom to mess with my HTML and not break my JavaScript in the process. So here's a concrete example. We're just going to do a little visual example here. Really simple. To-do list. If I check off one of these items, it's going to get marked with a completed state, and it's going to go away. So that's the behavior that we're going for. One sec. And it's broken because I'm not on Wi-Fi. My bad. So this thing should be hidden as I check it, right? And that's the example we're going for. Pretty simple. So I'm just going to walk through the code on how this works. We've got some HTML. We have a task list. Inside we have a task. And then inside each task we just have a checkbox and a label. So pretty basic. Now this is the JavaScript. I select my checkbox if it's inside of a task. I bind to its change event. If it's marked as checked, then I'm going to grab my parent task. This is the jQuery way of kind of grabbing the parent. And then I'm going to add the class completed. So again, you notice there's no CSS going on here except for the fact that I'm adding a class. The CSS gets to decide what the completed class or state looks like. And in addition, when it comes to the dependency on the structure, the only dependency this JavaScript has on what the markup should look like is that I have to have a checkbox inside of a class called task. I can have it 10 levels deep. I can have other sibling elements there. It doesn't matter. I'm not going to break my application by messing with the HTML as long as I always adhere to this basic restriction of having the checkbox inside of the task. So I have the freedom to mess with my HTML and to mess with my JavaScript without breaking one or the other. And then here's an example of the CSS. So we have our basic task stuff, and then our completed state has display none. So I could have got this job done by just calling .hide, but that's a bad practice, right? Because what if I want to change what the completed state looks like, or I want to add a CSS animation or something like that? Now I've got to change it in 2 places. So changing it here is a lot easier, right? I just go to one place, I update what my state looks like, my JavaScript already knows what the class name is, and I'm good to go. So here's an example of changing the CSS. So this is actually adding an animation. I've got the same base stuff I had before. Now my completed state has this animation called fade out. The other properties you see there are what it should have by the time that animation's finished. And then here's what the animation looks like. For the first 20%, we're fading the opacity. And then for the rest of the animation, I'm shrinking the height. So it would be this fade, shrink, and then it goes away. The cool thing with CSS animations is there are browser events for when the animations are done on the elements. So if I really wanted to know, or if I really wanted to do something like remove the DOM element completely once the to-do is completed, I can actually hook into the animation end event of the task once this animation is completed, and then I can execute a callback and remove it or do whatever I'd like with it. So the support is there. This is really a nice way to drive animation rather than using jQuery Animate or something, which is not nearly as performant, especially when it comes to mobile and tablet devices. So now I want to switch gears and talk more concretely about an actual JavaScript UI component, and we're going to go through some code and talk about kind of the best way to write this thing. So I'm going to show the visual example first. So we have, sorry, I wanted to come up with a really basic component, not something as complicated as tabs or a slider. So what we're going to do for the rest, our example is going to be this simple component where we're listening for mouse down, and then we're adding a class. Then we're listening for mouse up, and we're removing the class. So mouse down, add, mouse up, remove a class. The CSS is going to drive what happens when that class is added. So I'm going to mouse down on this element. CSS actually has an animation. When I mouse up, the animation is, or the class is removed, which reverses the animation. So mouse down, add a class, mouse up, remove. Pretty simple. Now, let's talk a little bit about how we might write this component. So first, I want to talk about approaches that are pretty common out in the wild for kind of like third-party UI components. The first approach is pretty common. I like to call the Blackbox Method. The whole point of the Blackbox Method is I have a component. It does something really specific. It does it really well, but you, the developer that's using it, you don't really need to know what's going on the inside. It's kind of this closed-off thing. There's not a lot of options, not a lot of flexibility. It just does what it does. Here's the HTML, CSS, and JavaScript. Go use it, and don't try to change what it does because you'll break it. So here's what it might look like for this component, right? I've implemented this thing as a jQuery plugin. That's pretty common for these black box components. So the syntax here, if you see the bottom line on the screen, that's where the component is getting initialized on this HTML element. And then this thing on the top is the constructor. So we're adding to the jQuery prototype so that this .secret thing is available on all jQuery objects. So the first thing I do in my constructor is I bind to the mouse down event, and then I call add class, and my class name here is show. Then I do the same thing. So on mouse up, I remove the class show. So it's the exact behavior that I outlined, that I said we were going to use, but the problem is that it's really specific, right? What if, as a developer, I don't like the class name show, and I want to change it to something else? Now I'm stuck with going into the source of the component and hard coding it in. And if it's a larger component, larger than this, it's a headache, right? So we want to kind of have customizability, and that's one of the big problems with this. So pros and cons, I like that this is modular. I mean, any kind of jQuery plugin, it's nice that you can take it around and reuse it. I don't like that it's too basic, and it assumes user ignorance, right? Like it does what it does, just take my word for it, kind of a thing. So the other approach that you may see, or that you may come across in your own personal stuff, who here uses a larger like JavaScript app framework, like Angular, Ember, Backbone? Yeah, really common, right? And a lot of those libraries have really nice ways to write UI components or UI elements. The problem is, by definition, if you do it that way, you've lost reusability, right? Now you're really dependent on this framework and how things are done in it. So just a quick example of a framework-based version of this same component, and we'll talk about why it's good, why it's bad. So here is a Backbone view that I wrote that does the exact same thing. So here I'm actually creating a class, the kind of the Backbone way. So I'm creating a view class. Later on, I'll instantiate it. And I'm setting some properties on it. So this element property can actually be overridden if it's passed in. So the default is to grab the secret element. This events object is really nice in Backbone views. It sets up this mapping between mouse events and methods that you fire. So here what it's saying is when a mouse down happens, call the apply method on this view. So down below we have the apply method, and it's doing add class show like we were doing before. And because it's a Backbone view, I decided to throw in some event stuff. So if you're actually writing an application that would use this, you might want to have some event-driven stuff going on. And Backbone does a lot of this. So I can trigger this event, and then I can listen for it outside of the component, and I can be notified every time the class is applied. So if there needs to be communication between components, this is really nice to have in Backbone. And then same thing with the remove class, right? So we have this nice event mapping. We have these events that trigger, or sorry, we have these methods that trigger events. And then here's where it gets instantiated. We just call it with new. So this is nice, right? Pros and cons. I like that it's event-driven. It's really awesome to have components communicate that way. It really decouples things, but it also allows for some sort of external API for each component. I like that it's cleanly organized. And the big con here is that it's Backbone dependent. Right now, if I want to reuse this nice clean code that I just wrote, I have to lug Backbone and underscore for that matter with me everywhere I go, which is not ideal. Or I have to refactor the whole thing and I end up looking like a Blackbox component or something. So we want to find the sweet spot. We want to take out these cons. We want to bring back the modular one that we had with the Blackbox approach. And then I'm going to add one more, which is we want these reusable solid UI components to be flexible and customizable. So we're going to try to do that. The way you should be doing this is with these two things. These are the big ones, okay? You need loads of options and tons of events. So what this means is any little thing inside a UI component should be customizable. You can provide some sane defaults so that it works out of the box, but you want to give the user the power to kind of override those defaults and maybe tweak the behavior to do something that you maybe didn't envision it to do. And this includes, when I say the other developer, sometimes that's you 6 months later, right? So you're saving yourself trouble by kind of building this stuff in. And then with events, again, if we go towards this event-driven architecture, it's really nice anytime something significant's happening inside the component, you want to trigger an event. And this kind of builds an external API so that other components can communicate or be notified of things going on within the first one. So real quick, I want to show some code on how this is done. The first thing I have to show you is kind of the base class of what all my reusable components extend from so that you have some context. So here is the base class. I call it Lego. It's using a John Resig's style of JavaScript inheritance here. So when I say class.extend, I'm defining a class, and these are properties that go onto the prototype of the class. So my default options by default is set to an empty object, and then init is my constructor. So my constructor for all of these components is going to take an element and then a set of options. Inside the constructor, I'm going to take the element, I'm going to wrap it in a jQuery object and store it on the instance. Then I'm going to take the options that were passed in, I'm going to override it, the defaults, and I'm going to store that in another object called options on the instance. And then we have a couple utility methods for doing the event architecture stuff. So if I want to trigger an event, I can do that. If I want to bind to an event, I can do that. In this case, I'm using jQuery's little hack. So for those of you that don't know, with jQuery, you can take a plain JavaScript object, you can wrap it in a jQuery call, and you can trigger arbitrary events just like if it were an actual DOM node. And that's actually what it's doing under the hood, is it's using DOM events. So it's not the most performant event system, but I'm just using it for simplicity in this case. So the idea here is that all of our components that extend from this class will have the ability to trigger events and bind to events. So let's go ahead and look at the actual code. So here it is. It's a little bit bigger than even the Backbone example that we looked at. It's a lot bigger than the first one. But I'm going to argue that it's more reusable, more robust, can do a lot more for your buck. So let's kind of step through it. So we have this class called secret. It's deriving from the base class that we just saw. In my constructor, the first thing I do is I call my parent constructor so that I get the this.$element and this.options with the override of my defaults. So that's all set up for me. Then the next thing I do is I bind to an event on the element. The event is actually stored in that options object. So before we were saying that the behavior of this component was mouse down, add a class, mouse up, remove a class. I'd like to argue that we shouldn't be stuck with that mouse event, right? If later on down the road I really want to choose a different event to bind to, I should be able to pass that in as an option rather than changing the source of my component. So here, it's a lookup into whatever the options are. Our defaults define a few, right? We have the class that's being applied, which is show. We have the apply event, which is mouse down, and the remove event, which is mouse up. So by default, my apply event will be mouse down. But if whoever's using this component has passed in an option to the constructor, that will be overwritten and it will be whatever they set it to. So we're doing this lookup when we're referencing our events and the class name. So I bind to the apply event, in this case it's mouse down, then I call apply. Here's the apply method. It is, again, calling add class, but again, the class name here is a lookup into that options object. I'm not just adding a show class. So again, that's really nice because a lot of the times what I find as I move from project to project is CSS naming schemes change. A class name like show might not really be what you want to be toggling. So you have the ability to override it when you call the constructor. Then the next thing I do is I trigger an event. So now I'm triggering this event called secret-apply, and any other part of my site or application can actually listen in for that event and do something with that information, right? Like, oh, this component just applied its class. Maybe I want to change my state or do something in response. And then I do the same thing for remove, right? I'm binding to an event. Again, it's a lookup, calling remove, which is removing my class, and I'm triggering a separate event, secret remove. So that's the whole thing. A few more steps to jump through than a normal component, but again, I'm going to argue that these options and these events kind of help us extend the basic behavior. So I want to show a few examples on taking this plain component that we built and doing something a little extra with it. So here is an instance where I have two of these things. So the one on the right behaves the same. Whoops. Sorry, one sec. Let's try that again. So the one on the right should behave the same as the one we saw before, right? I'm just hiding and showing something, adding and removing the class as I mouse down and mouse up. The one on the left is going to behave the same, only notice that it's driving the one that's on the right-hand side. So we kind of have this master-slave relationship, right? Not the coolest example I know, but it gets the point across. So if we want to take these two components and let them communicate, we can take advantage of our events. So here's what the code looks like, right? We already had our class implemented, now we're using it. So we instantiate two of these things. One is the one on the left, two is the one on the right. And then we listen in to the one on the left's secret-apply event. So we know it's triggering an event every time it's adding its class. So we listen in on that event, and we respond by telling 2 to call its apply method, which will apply its class. Then we do the same thing on remove. So now these two things are in lockstep, and I only had to write a little bit of code to kind of extend my basic behavior here. So one last example, I wanted to kind of show off overriding the options. In this case, for our component, the options had to do with the mouse events. And I kept thinking about an example that would use something like mouse over. And what I landed on wasn't just changing the last example to use mouse over. I made this little animated GIF scrubbing thing. So I took this animated GIF, I extracted out all of the frames into like 91 different images, and I set up some HTML and some CSS. So this rectangle that you see on the screen, which has the image, actually has a bunch of invisible slices laid on top of it. Each slice is set up as one of these secret components, and it's listening for a mouse over event, and then it's adding a class to itself. When the class is added, it shows a specific frame of the animation. So this is what happens as I mouse over. I get this kind of scrubbing the animation feel, right? I can go forward in time, backward in time. I can jump to a specific frame. And just to give you an idea of how the HTML is set up, here's kind of the debug mode, right? I have all these little slices on top, and you can see that only one's active at a time because none of them are touching, and each of them is active because I'm mousing over it. So I've just changed the mouse event to mouse over and mouse out for remove, and I've got something way more interesting than what I had before. And the cool part is, this is the code. So I already have my class set up. I just iterate over all 91 slices. Again, there was some HTML and some CSS that I had to put into this, but the JavaScript is simple, right? So I've got my slices set up. I iterate over each of them. I instantiate a new component, the secret component on it, and then this time I'm actually passing an options object as my second parameter, and the options object says my apply event is no longer mouse down, it's mouse over. My remove event is going to be mouse out, and that's it. That's all I had to do. So Just as a recap, I hope you guys got something out of the UI patterns, just a general understanding of kind of these underlying behaviors. I hope that can help you as you go forward. Again, I know not everyone in here has the time to kind of roll their own UI components, but I hope at least you know what to look for when you're out there looking for third-party components. Lastly, before I let you guys go, if you're interested in any of the code examples or this general kind of widget framework, I've kind of started writing some in a repo on GitHub, so check out this URL. Again, my slides are up on tybenz.com, so you can get to this link from there as well. Yeah, I think that's about it. Thanks a lot, guys.